So today's second class of mathematical logic. Today we will discuss predicate calculus, okay, or predicate algebra. So, yesterday we have discussed proposition logic. So what we discussed actually, what is mathematical logic? What is mathematical logic? From given premises we have to find conclusion. After that there is inductive logic and deductive logic, that difference. Then proposition logic, basic connectives, then simple example, truth table. These things we have done yesterday. Few questions we have done yesterday. Now today we will do predicate logic. In predicate logic we have studied that quantifier is important thing. What is quantifier? Quantifier means how many elements are there. Universal quantifier means for all, and existential quantifier means there exists at least one. So for all x px means p1 and p2 and p3, like for every elements, and there exists px means p1 or p2 or p3 or p4. So these example we have understood that universal quantifiers are often used with, okay. So we have seen that for all x we will use arrow sign, okay, that is clear, and with there exist we will use and sign, okay, and with there exist this is not used, okay. Now we also have seen that switching the order, if both are for all x and for all y, we can switch this left to right. But if there is for all x there exist, then we cannot switch this. Then meaning will also change. For example, for all x there exist y likes xy. What is meaning of this? Means what is LXY? X likes y. So for all x there exists y likes xy means for everyone likes someone. Is it clear? Means everyone like at least one person. This thing is clear? But if this is changed, there exists y for all x likes xy. What is meaning of this?
There exists y.
At least one person means there exists at least one.
That likes all x.
Yes, who likes everyone.
Yeah.
Okay. Here it is written someone is liked by everyone, but actually there exists at least y. Oh yes. Here this is also important, that where x is written and where y is written, okay. For example, if I write there exists y for all x likes yx, what is meaning of that?
At least one y likes all x.
Correct. At least one person exists who likes everyone, and if it is xy, then at least one person, yes, here it is written someone is liked by everyone.
There is for all x, so if we change it to x comma y, then what will be the line?
Here if we change,
No, for that statement.
this statement,
No.
this one,
What will be the sentence?
if we change
No, only this.
for this change,
Yeah.
this is someone is liked by everyone. Why? Someone means at least one person exists in this universe, okay, who is liked by everyone, because here it is y.
It is kind of that passive voice.
Yes. It is, means actually we can express better in passive voice. But for mathematical logic there is no passive or active, okay. But Is it clear? Now what happened if you change here like yx?
Liked by all x, like there exists
For all x, yes,
like there exists at least one y who is liked by all x.
correct, correct. So again, for this we have to speak like
Active was
yes,
active
yes,
down.
yes, yes. If you change this, then it is actually what is active and passive. There also it is changing the location of the subject.
When the order is changed.
Correct, correct. And this is what? This is subject.
Yeah.
So if you change the subject from here to here, then that is the active passive. Is it clear? So this is what is a predicate? Predicate is a proposition where subject is variable. So when there are two subjects, if you change the subject position, active will be passive and passive will be active. So that is a good observation. Is it clear? Now this also we have seen yesterday. Yes, that what is this? Actually this is De Morgan's law. Okay, if we have for all x, means it is something like this: p1, because it is means it is like this, not of p1 and not of p2 and not of p3, like this, and so if we do not of this, definitely what will happen? P1 or P2 or P3. Okay, or you can say this can be written like not of this. So this is what? There exists x px. So not of there exists x px is equal to this one. Similarly for all these things. Okay. Quantified inference rules. So again, there also we have seen modus ponens and modus tollens, those things. Those are what? Inference rule. From something we can conclude something, means from given some premises we can conclude this. So from all x px, can we conclude PA?
How it is
Yes, if I write for all x px,
what is a?
means anything, means if I'll say that for all x sx and sx is x is student. Okay, now what does it means? For every x this thing is true, means every x is student. It means what? If I'll put any a or any b, or if it is I'll put Ram, then Ram is also a student. Means if it is true for everything, then for one thing definitely it is true.
Okay, a is one of the thing from x.
Yes, a is one of the thing from the universe, and universe is for all x px, means this x must be from some universal set. Okay, got it? So this is true, but opposite is not true, converse is not true. Correct. Now universal generalization. Similarly, if it is true for all these elements, then you can write this. So that is okay. What about this existential instantation? This is what? There exists x px. Now it means, what does it means? Means there exists at least one person for this. This is true. Okay. So then we can imagine that
There will be at least one person, or
at
there
least one
exists
person.
Only one person.
No. At least one person, not only one person. Why? because it is P1 or P2 or P3, something like this. So it may be 1, maybe 2, maybe 3, maybe all also, but at least one. Here or is this. Okay. In GATE exam, sometime it is asked exactly 1. So exactly 1 is different than at least 1.
So for that,
How to write for that? So exactly 1 means you have to write there exists x, means something like this, there exists x px there exists x px and for all x you can put here okay, for all y not of py, okay, where y is equal to capital X minus x. You got this thing? There exists x px means maybe 1, 2, 3, 4, maybe for n elements it is true. Okay, but again I am doing 1 and means it is not true for all. Not true for all, it means it is not true for anyone. But what is y? Y is equal to x minus x, means for only one element it is true. Is it clear? So this type of expression is equivalent to that thing, that only one exists. Is it clear? And this will be written before this. Okay.
small x is that excluding that
Small x is for this x and this capital X is universal x. Okay. And y is this y. Is it clear? Any doubt? Now Skolem constant. Skolem constant, these things are important when we use predicate calculus in artificial intelligence. Okay, means what we are using here, there exists x px, then we can say for some x this is true. So actually PA and PF is just difference in nomenclature, but here it is for at least one f it is true. So we can put some f, for that it is true. Okay, we'll see later that how it is used. Okay. Existential generalization is easy. If it is true for one x, then you can say that there exists x px. So roughly you can say if it is
this question is directly linked.
sometimes directly, but normally what happens, digital logic is mixed with TOC, sometimes it is mixed with computer organization, and then it is asked. For example, they will ask that do you know push down automata and these things? No. So later you will know. But there are some direct question also that we will cover here, and those questions which are mixed with some other topic, that we will cover later, because without knowing that subject we cannot do. Okay, because logic is important, but actually logic is a tool. When you understood the logic, then you can, using that logic you can understand other subjects. Okay, it is used in AI also, it is used in computer organization also, it is used in TOC also. Okay, and mostly, for example, operating system, then this network, everywhere it is used. Okay, Oh, clear? Now, for all x px is true, then pc is true where c is any constant in the domain of x. Okay, right now do you understand this thing, domain of x and domain and range? What is domain?
Like the inputs, the values of x, and range is the output.
Correct. You are right. And what is difference between range and codomain? Okay, no issue. Range is subset of codomain for which pre-image exists. Okay, that thing we'll read when we read set relation and function. Okay, just after this we'll go to that topic. So for all x px is true, then pc is true where c is any constant in the domain of x. Okay, so this here, if c is any constant and if this thing is true, then for any x this is true. That is what we have learnt here also. Okay, in here also same thing we have seen. So here example is given, for all x jiggy eats x. Okay, so we can write jiggy eats anything, means it may be ice cream, it may be anything. Okay, so this is true for always. Okay, the variable symbol can be replaced by any, so this thing is clear. But if there exists, then you cannot put this. Is it clear? Now for existential, there exists x, it's jiggy x, this. Now here this cannot be anything. This must be a specific thing only. Okay, and how that will be done, that we'll see later. Now for some simple example, these things can be asked in GATE exam also, and if you see previous year GATE question, we will found some questions like this. What we will write, every gardener's, one important thing, when this thing is given, then reading is easy, but writing from scratch is little bit difficult. Okay,
So it comes with practice.
yes, it comes with practice, because this is also a language. So it is also do you know Prolog, this language? Actually pro means programming and log means logic. So for logical programming there is one programming language which is used nowadays, especially with Python and Prolog. These two languages more used in AI. Okay, and Prolog is very much similar to first order logic syntax. Okay, now you try to write for this, every gardener likes the sun. If every gardener likes the sun.
For all x.
You try to write yourself this one. Every gardener likes the sun. Yes, so likes, so like must be, there must be some predicate, so you can represent it by L. Okay, LX means, so you understood this thing? Now this is little bit difficult, means you can fool someone of the people all the time.
Some of the people means there exists.
there exist, correct. So there exists some person, means there exists x and person x. You can write px for person x, and every time you can, time can be used like t. Correct. For every person, yes, yes, it is correct. Okay, now look at here, because here it is all the time. So what we have done, for all t, time t. What is meaning of this? What you have written? For all x, but where is time? For every person, if he is person, then x correct. So x can fool that person. You can fool some, you can fool some of the people all the time. So all the time, correct. So actually this is also correct in some predicate.
Some of the people and all the time are joined with and. I mean.
Yes.
Okay.
So actually what is the thing? Actually this depends that how you are writing this predicate. That is also important. Okay. For example, if you are writing can fool xt or it can fool xy, it means x can, what is meaning of this? X can fool at time t.
And for all the time there is that.
For all the time, this is this thing. Okay, so this is important, that how this is written. Okay, and in GATE exam, predicate will be always written. Means this thing is always written, because this is more tricky, that how you are making the function. Function is this one.
In exam, do you have to identify the sentence or the expression?
Both. Yes, sometimes this thing is given and you have to make the expression, and we'll see in later. Okay. Now this, if this is the correct one, then try to write for this. You can fool all the people some of time. Some of time means there exists t. Yes. For all x px, if one thing always remember, that whenever you have with for all, then definitely there is arrow sign, and if there is exist, then there is and sign. Then only meaningful sentence will be created. Okay. For all x, person x, here it is x. So for you have to bound here with x, then only it is clear that person is x or people is x. Okay. If it is, and there exists a time. Okay, there exists a time. Then You can fool all the people some of the time. Yes, some of the time. Yes, so this is also one representation. Okay,
It is correct.
it is for every people, and but actually what happened here, bracket also makes a role. Why? Because this is related to, if you are bracket this one, if bracket is here, but
This all of the people and some of the time comes together.
Hmm.
So I did it with and.
okay, you can fool all of the people at some of the time. Okay, now look at here. If someone is person, for every person, there exists some time x can full, means at time t. This one, this representation. This is easy. If he is a person, means for every person, at some time you can fool. For every person, at some time you can fool. Is it clear? So this is more easier. Now come to this one.
So this one is wrong.
This one is not wrong. Actually, this is not making meaningful sentence. This is not giving some wrong representation. This is somehow correct, but what is the issue with this? As I told you that with for all x you always write arrow sign. So you look at here, with for all x arrow, and when there exists it is with hand. When you write like this, it is easy to write. So sometimes it is more confusing, like this in this example. Okay, clear? Now look at here. For all x there exists t. Okay, actually this is nothing but this t came here and then this is written. Okay, now both are same. Just it is now why this copying this t to here is not changing this sentence? Earlier what I told, yes, if for all and there exist, these things cannot be interchanged. Okay, meaning will be changed, but here it is not changing. Here we are easily taking this side. Why? Because here there is no t. Here there is no t, so if you keep this t here, the meaning will be not changed. Is it clear? But if you keep this all x here, meaning will change. Actually then there will be no meaning. That is not a valid formula, because here x is not associated with this. This thing is clear? Means you can copy this if there is no bounded variable. Okay? Means you can copy the bounded variable if it is not associated with any function. Clear? Now this is easier one. All purple mushrooms are poisonous. This is easier one. All purple mushroom. So you make one predicate, mx means it is mushroom, px means it is purple x, and poisonous. Correct? So this is easy? Yes, this is correct. Okay? No purple mushroom is poisonous. Now are those things are opposite? All purpose, correct. All purple mushrooms are poisonous. No purple mushroom is poisonous. Actually, both are opposite. And what is not? If I, what is not of this sentence?
Contra.
No, contrapositive are same, not.
Inverse.
Yes, inverse you can think like this. So actually, inverse is what? Inverse is not exactly not. Inverse means if it is a conditional statement, inverse is this. Okay, and what I am telling about this, not of this statement, or negation of this statement. So what is negation of this statement? Can you write negation of this statement? When this will be negation, what happened? This will convert to there exists X, there exists X, negation of mushroom X and purple X poison X. Okay,
You repeat this one.
I have written for all X, so that will convert it into there exists X. Mushroom X is mushroom X only, and purple is just I am representing P, and mushroom M, and this is poisonous, PO is poisonous. So I have written same thing but with not. Okay,
This is the expression.
this is the expression for negation of this statement. This is not same as this is negation of this statement. Now what happened?
So negation of for all is their excesses.
Negation of,
For all.
yes, negation of for all is what? Just a minute. Negation of for all is what? There exists X and negation of Px. This one. De Morgan's law. Like negation of there exists is what? For all X. This. Is it clear? So negation of for all X is there exists X. Means if I'll say that everyone in this class is intelligent. So what is negation of that?
None in the class are
No. So that is what I want to tell, that is not negation.
I mean the opposite.
Yes. Now opposite, meaning of opposite is also a means
So
having
everyone
dual
in
meaning.
this class is stupid.
Everyone in this class is intelligent. What is negation of that? At least one student in this class who is not intelligent or who is stupid. Why? Why your statement was not correct? How to check that one negation is correct or
Because I used everyone. So I kept it same.
yes, you are right. But how I check mathematically? Means if A and A bar equal to 1 or true, then only what do you mean by negation? Negation means A plus A bar equal to 1, then only you can say that. And one more thing, A dot A bar should be 0. If these two condition is satisfied, then only you can say that is negation of that statement. Is it clear? Now you think about your sentence. Means I am telling that everyone in this class is intelligent. Now you are telling that none of the students are intelligent. Now you combine union of those. Means you will find some students. 1 minute. 1 minute. 1 minute. I'll see. If there are two sets.
So basically that becomes 0.
Yes, if it is in this class, this is the whole class, intelligent and not, actually not intelligent is the whole set. So now what I am saying, that everyone in this class is intelligent, okay, and another sentence you are saying none of the students, means no students are intelligent, so you are saying that all students are stupid, okay. Now when you union both of this, what happened? Nothing means
Both the statements contradict each other. So
is it clear? Both is
so the result is 0.
result is 0. What happened when you do AND of both students, both statement?
Like everyone is stupid and intelligent.
Mm-hmm.
That doesn't make sense.
Okay, 1 minute. With same example, it is better to use mathematical thing. Okay, you if I'll say that everyone is intelligent, okay, and no one is intelligent, okay. Both, what I am telling, that both are not complement to each other, okay. Why both are not complement to each other? What I am saying that everyone is intelligent. What is complement of that? At least one student who is not intelligent, okay. Why? Because when you combine both students, means, okay, 1 minute.
It should
Okay, just a minute. P1, P2, P3. What is complement of this? What is complement of this? P1 or P2 or P3. So what is complement of this? Yes, not of P1 and not of P2 and not of P3. This is correct? Anything else is complement of this? This one is correct, De Morgan's law only. Now if P is what? P is intelligent, okay. Now what is okay, similarly this is also correct. P1 and P2 and P3, not of this is what? Not of P1 or not of P2 or not of P3, okay. This is correct, both are same. Now if P is intelligent, everyone is intelligent, means P1 is also intelligent, P2 is also intelligent, P3 is also intelligent. Similarly for P4, okay, everyone is intelligent. What is negation of that? P1 is not intelligent, or P2 is not intelligent, or P3 is not intelligent. Is it clear now? Everyone is not intelligent, it is not saying this.
Yeah,
Got this? So now you understood that when we speak something and negation of that, so that thing and mathematical negation both are different. What do you mean by mathematical negation? Means when you do or of these two things, this is equal to 1. When you do and of these two things, this is equal to 0. And what is your statement? Can you write that in sentence?
according
none of them is intelligent, it means
And
yes. Meaning of that was P1 and P2 and P3. So this is not equivalent to that. Is it clear now? Okay? Okay. Any doubt here? Because this is very easy thing, but this is very confusing thing. Okay? Because it looks, means in natural language, opposite means sometimes whole opposite, but negation is not exact that opposite. Okay? Now negation of this statement.
so this is the actual meaning of negation, like in English when we just,
Yes, yes, this is the actual negation.
so what we say those are wrong statements sometimes.
Yes, mathematically or logically those are wrong statement, and that is the problem. When we do artificial intelligence, we have to consider that what we are speaking, that is not always correct. Means meaning of that statements are different. Okay, we'll see many questions. Sometimes in exam also comes. We see like, okay, you write one example. Try to write silver and gold ornaments are precious. How to write that? Sx is silver, Gx is gold, and Px is precious. All ornaments or all silver and gold ornaments, means Sx is silver ornaments, Gx is gold ornaments, and Px is precious. So if I am saying that all ornaments are precious, means all silver and gold ornaments are precious. So this is what you have written. Okay, now try to understand meaning of this. What you have written, Sx and Gx. What is meaning of this Sx and Gx?
Silver
Which
and
is silver also and gold also. Is it clear? So what should it be? For all x, if it is silver or gold, it is Px. Is it correct? We are telling that it is silver and gold, but meaning is or.
Yeah, I mean there is a difference in the statement and
Correct, correct. So here the language which we are saying that silver and gold are precious, meaning is different. Meaning is it is silver or gold, both are precious. Although we are saying silver and gold, but meaning is silver or gold. So that is the difference in natural language and in mathematical language. And that is what in exam also those types of question will ask, where you think that it is you have to understand the meaning, and based on the meaning you have to write it. Okay, clear? This is also means maybe in 2004 or 5 this question came in exam. Okay, that is clear. So you have always not always going in terms, means not in literal meaning, actual meaning is important. Okay, now not of this sentence. Do this negation of this sentence. Do yourself. Now I think you can do. You have written here mushroom and yes, this one. You would write only M.
if I write negation of all, so I can directly write there exists.
Correct. There exists and negation inside here. Means this will become there exists and here negation will come.
Outside the bracket.
Yes, outside the bracket. Why? Because this whole thing will be negated. Look at here. For all x, negation, so there exists x and the whole thing will come. Okay, so go ahead. This is correct, but after that what happened? So this will become there exists x not of mushroom x and purple x, means purple mushroom
This
is
should be
poisonous x. So when you do not of this, what happened?
the and will get converted into
Yes.
and
So this what is not of conditional statement? This is what? Not of A or B. So what is not of this?
A
Correct. A intersection or A and not B. So not of this statement is this and not of B. So there exists x, this, mx and means purple mushroom and not poisonous. Now what is negation of this statement? All purple mushrooms are poisonous. So negation means there exists at least one, what is meaning of this? Purple mushroom. There exists at least one purple mushroom which is not poisonous. Is it clear? So all purple mushrooms are poisonous. Negation is at least one purple mushroom. At least there exists at least one purple mushroom which is not poisonous. Okay? Clear? And okay, now no purple mushroom is poisonous. How to write this? So if it is purple mushroom, it is not poisonous. Is it clear? So this is very simple statement. If it is not purple mushroom, it is poisonous. What is negation of that statement? No purple mushroom is poisonous. What is negation of that?
all
Mhm.
mushrooms.
No purple mushroom is poisonous. So negation is what? At least one purple mushroom which is poisonous.
But
Yes, again that same thing.
but
Mhm. Yes, yes.
all the negation is there exists. But
Yes.
is not,
Yeah. So no purple means all purple mushroom is poison. Means no purple mushroom is poisonous means what?
all
Uh, Yes. Means no purple mushroom is poisonous. Means if it is purple, yes, it is confusing. That's why separate logic, mathematical logic is there. And we are focusing only on those parts where it is confusion. Otherwise, simple parts we already know. Without this also we can do. So we are focusing here only. So no purple mushroom is poisonous. So what here it is very simple. If it is purple mushroom, it is not poisonous. So no purple mushroom is poisonous. Now what is negation? at least one purple mushroom which is poisonous. Is it clear? Any doubt? Confirm? Okay. So what is easy way to do that? Again same thing. For all x, we'll convert it into there exist, and then not of this, so this will be this one. So both are same thing, because here one thing is here not, means this is like this. Okay. Now this is what you were earlier we thought that at only one purple mushroom like that. So there are exactly two purple mushroom. So how to write this?
So there will be 2 times there exists.
Correct. So there are exactly two purple mushrooms. Exactly two purple mushroom means only two instances true for that. So it is better to look at here than you try yourself, because from scratch it is difficult. There exists x, there exists y. Mushroom x, purple x. It means x mushroom is purple. Okay. Y mushroom is purple. So two mushrooms are purple, x and y mushroom. And x can be anything here. It is, if you write only this thing, it means more than 2. Okay. Now, and x is not equal to y. X is not equal to y. Why? If x is equal to y, what happened? It may be then there is only one purple mushroom. So if you not xy, it means x and y are different. So if you write only this, meaning of this is what?
I mean 2 individual purple mushrooms.
Yes. If we not like these things, meaning of that it is more than 2 purple mushroom. Now what we are doing, for all z, if it is mushroom and purple, z means some third variable. Means if it is purple mushroom and purple, it means purple mushroom, and x is not equal to z, okay,
No, but it is
or y is not equal to z.
it is x equals z.
It means what? Whenever conditional statement is given, what do you mean by that? First condition is not true. Okay, first condition is not true, or second condition is true. That is clear. I have already focused on that. Now here again we are writing for all z. Here one conditional statement is there. It means what? Purple mushroom does not exist, because it is written in left side. Is it clear or no?
Can you repeat the first statement is clear.
This statement is clear. First statement is what? X is purple mushroom. Then y is purple mushroom. X and y purple mushroom. Now what I am telling, that x and y are not same. It means there are at least 2 purple mushroom. X and y. X is also purple mushroom. Y is also purple mushroom. And maybe more than one purple mushroom exist. Is it clear? Now how to construct that number? Now I am doing AND with one more condition.
What I understood, can I tell?
Yes, please.
So basically, there exist 2 purple mushrooms.
Yes.
Which are not same.
Yes, this is.
And Z represents the remaining mushrooms.
Yes,
Such that the first mushroom lies with the that x equals z means it is one of the mushroom out of z.
correct.
Yes,
You are right. Yes.
And similarly, y is one of the mushroom out of z.
Okay. So
Like this.
You are right. Means you understood it, but how you are sure that there is no third mushroom? Because our point is exactly 2 purple mushroom. So how you are sure that there is exactly 2 purple mushroom?
Then why the Z is?
Yes, that is what I am telling. Just a minute. Till this point it is clear that what is meaning of this, that more than 2 purple mushroom exist. More than 2 purple mushroom exist. This thing is clear. Now what we are saying, for all Z, okay, this condition is there. Okay, now whenever there is any conditional statement,
So why did you write more than 2? Only
okay, what if I write there exists px, means more than 1 is exist. If this thing is not written, what does it mean? Mushroom X and purple X means at least 1 purple mushroom exists. At least 1 means what? More than 1.
Okay, so does Z represent the
Just forgot Z right now. First understood this thing. With X, this thing is clear that if only X is written, it means at least 1. Means, okay. Now if you write till this thing, means if you are not doing this thing, what is meaning of this?
means like there
Same thing, at least 1 only. Means there is nothing extra. Means if you are writing only this thing, it is not adding anything.
I mean basically it's like there are 2 sets of purple mushrooms. One is X and one is
Correct.
Y.
Correct. 2 sets of purple
That
mushroom.
represents that X minus 1 and Y minus 1 mushrooms.
X minus 1. Why X minus 1?
Because there should be exactly 2 purple mushrooms.
Correct.
So if I have 2 sets like X and Y, so I take 1 mushroom each from one set, so it becomes 2.
Okay.
that-
Yes, you can think like that. Yes. Oh, you are adding this Z also. Okay, correct. Now I just want to tell you means easier representation of this thing. Then it is,
My thought is
your thought is correct. Okay, but I just want to think like this way also. This is clear that this is just mushroom, and if you are adding this, it means more than 2 mushroom, more than 2 purple mushroom. And if I am writing for all Z this thing, what does this mean? If it is written like this, it means not A or B. This is clear. So it means no purple mushroom exists for first one. And if purple mushroom exists, then X equal to Z means this one, or Y equal to Z, this one. Means no other purple mushroom exists. Is it clear? Now can you write there are exactly 1 purple mushroom? That is easier. How can you write?
exactly 1.
Yes, exactly 1.
So I don't need Y.
Yes. So write down. That is easier one.
Can I take help from this?
Yes, definitely you can take help from this. Write shorter name, it will save time. predicate name, actually in presentation I have written the full name, but it is better to write short name if you are. You have written? So why you need y, x, z, three things?
No, Z and X.
Oh, z and yes, then it is correct. Mushroom x. Okay. Mushroom x and means purple mushroom. If it is purple mushroom, but if it is purple mushroom, then for all z, here why you are using this sign?
Then what?
Again you are doing that same mistake. Whenever there is this, there is always and sign. What is meaning of this? Meaning of this,
So here there should be and sign.
yes, it should be and. Is it clear?
Yeah. Like with their X's.
Yes. So what you have to write, no need to write y, there exists x, mushroom x and purple, okay, and this only, and after that you no need to write this, and z is this, again mushroom means purple z, you don't have to write this.
Yeah,
Same. Okay, clear? Any doubt? So now I think this was we are trying to write earlier. Oh, I have erased. For at least one we have earlier also tried. Now this thing is clear that how to write at least one. Okay. So at least for at least one also we have to write there exist, and we have to write that for all that thing is not exist. Is it clear? Not is very easy. Okay, now it is better to go some question. Can you solve this? So this is the gate question. So one thing is important, if pure proposition logic question is means you can is normally pure proposition question is not asked, they'll always mix with some other thing. So here it is mixed with concept of composite and numbers. So you know what is composite number, which is not prime is composite. Perfect square you already know, prime number you also know. So now you can solve it. So first you have to understand what is this one. note of this. So P or Q?
Yeah, maybe
Yes. So but you have, this is equivalent to this one.
no.
One.
This one is equivalent to this one. This one is equivalent to this one.
Okay. Some yes, not will be cancelled. So this one is definitely this one. But here it is
This one means not of P.
P or yes.
Okay, this will be the inverse.
Yes.
Yeah.
So actually this is not of P or Q, and not will be here. So
So P inverse Q.
P and not Q.
Why is it so confused?
Yes. Okay. P and not Q are and S. Yes. Now it is okay. Clear? You also think like this: if there is any conditional statement, what is negation of that? Means earlier also I told that if I promise something, for example, if I'll say if you are coming Delhi, you are selected in gate. So what is negation of the, means when my statement is false?
If I don't come at least.
No, my statement will be false only at one condition, that you are coming daily and then also you are not selected. That is only the condition. Means first condition is true, means if you are coming daily and you are not selected, in only that condition the statement is false. So negation of conditional statement, first statement must be true and second statement is false, only that condition. Is it clear? Why I am telling you to think like this? Because you understood this also and you understood logic also. What is the advantage of that? Means when you write, the chances of wrong calculation will be less. Now it is easy. Now you just have to think in this term. So what is P and not Q? P and not Q means which numbers? Which is not Q. And similarly,
11.
correct. P and not Q is 11. Yes. X is a composite number, so it must not be composite number. So all numbers are composite only, so only 11.
And perfect square and
Prime number. So what are the perfect square and prime number? Is it possible?
like 1, 4.
If it is prime number, definitely it is not a square.
So it will be 0.
Yes, it will be 11. Yes, that is 0, but it is with OR, so is it clear? Okay. So actually this is the basic thing. Mainly the proposition part is this one. You have to solve this one. Okay. After that it is applied into some other thing.
Okay, so are these questions easy for all students preparing for GATE, or these are like this? Like students find it difficult or easy?
It depends. It depends. Actually, if it some person try to solve aptitude and this portion more, and some what are these questions? Actually these questions are based on more aptitude. Means if you understand the thing, then you can easily solve this. But in many parts, you know the formula, then you can easily solve. But here actually there is no formula. If you understood, then there is no formula. If you don't understood, then maybe you need some formula, but if you understood then. So it depends that this is easy or definitely, because there is no formula, then making question in this is more difficult. Solving I cannot say, but creating question here it is more difficult, because you have to think that without any other thing you have to make question. Is it clear? So because it is gate question, so similarly similar question is asked in gate. Now next, this is easier, you have done.
These questions come in that aptitude section.
No, 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 not in aptitude, in computer science section.
No, in computer science, like there is that 30 marks for non-tech and rest 70 marks for.
In 70 marks. In 70 marks. Although these things will help for 30 marks also, but this is for core computer science. This is in syllabus has two parts. One is aptitude, which is common for all, and another is computer science. So this is for computer science only. Although this will help there also. So tell me. So this is very easy. Actually, you don't have to write anything.
It's Q.
It's Q. Why?
That first.
Ponem, modus ponem one. Okay. Oh, no, you are right. Answer, consider the following expression. The number of expression given above. Yes. So actually this is not, yes, that is the trick. You are right that Q is 1. Now question is, now you read the question again. The number of expression given above that are logically implied by this. So actually you have to tell that with this, which among, if this is, can you imply this P or Q? Because from this P and Q is
If I break this
Mhm.
expression, so
correct. You are, so from this you can conclude that this is P and Q. This is easy. We have done earlier also from this whole statement. When we are proving modus ponem.
okay, yeah.
That is okay. So from this we can see that okay, this is equivalent to P and Q. Okay, P is also true and Q is also true. P is true because here it is already given, and Q is also true because of this. Now you have to tell that from this can you conclude these things? Means which among them is true? Number of expression. So Q is true, that is 1 is correct. But what about P or Q? You know P is also true and Q is also true. So P or Q is also true. So definitely this is also true.
But it should have been inverse. You wrote that P, Q,
You are telling about this. Yes, that is correct. But I am telling that from this, okay, from P, can you conclude P and Q? No. If P is true, from P you cannot say P. But from P you can conclude P or Q. Is it clear? So from this you can conclude this. Even you can, so from P and Q you can conclude what? You can conclude P also, you can conclude Q also, you can conclude P or Q also, you can conclude P and Q also, many things you can conclude. And because this is P and Q, so you conclude these two definitely. So can you conclude this also?
Yes.
Okay, why? Because from P you can conclude P or anything, means Q or Q bar or anything. So P is true, you know, so that's why you can conclude this also. Is it clear? So these three things definitely you can conclude. Now, what about true and false? This is clear that these three things you can conclude. What about true and false?
True.
True you can conclude. Okay.
If Q is true.
From P, what you can conclude? If from P you can conclude true, if this is written, what is meaning of this? Not P or F. So this is equivalent to not P.
How did that?
Oh, sorry. Not P or, yes, you are right. Not P or true, yes. So this is equivalent to true. So yes, and what about this? Not P or F. So that is equivalent to not P. Okay. So if it is true, so true can be employed, logically employed by any formula. Means P can be anything. P can implied true always, means, okay. So only false is wrong. So here answer is 4. So now you think that this is very easy question, because just by looking at it is modus ponens, so you can easily say that Q, but answer is not only Q, answer is 4. Is it clear? So that is the means that's why this is a great question. Yes. Okay. Now it is clear. So type 1, there are 2 type people. There is only 2 type people, means only type 1 and type 2. Type 1 people always tell truth, and type 2 people always tell lies. You give a fair coin to a person in the room without knowing which type he is from, means he may be telling truth or he may be telling lie, and tell him to toss it, okay, and you consider that he will toss it, okay, it is also true, and hide the result from you, okay, till you ask for it, okay. Upon asking, the person replies the following, okay. You have to consider that the person is doing all those things, means what you are saying that he is doing, okay. The result of the toss is head if and only if I am telling the truth. Now he is telling truth or not, that is also not true, because he is
The question is so confusing.
yes. So that is the logic. Then only you have to. So what he is saying, the result of toss is head if and only if I am telling the truth. Yes, you have to try.
So is it like this, that if and only if I'm telling the truth, the result is head, or other else it's tail?
Yes. If and only if means vice versa is also true. Means if it is only in one condition, then inverse is not. So what is the easier way to solve this? How you are trying to solve?
Is it MCQ or multiple correct?
Multiple may be correct. In GATE normally two types of questions, means if multiple correct, then there is normally no negative marking, something like that they will do. So what you have to consider is type 1 is telling truth and type 2 is lie.
So I think one of the answer will be option C.
If the person is type 2, means he is telling lie, then the result is tell. Yes, it is not heard. Yes, that is correct. This must be correct. If the person is type 2, then result is tell, because yes, that is correct. There is no doubt. Now, what happened? So actually now this is clear that one portion you have solved. Now for if he is the type 1, what happened? Type 1 means
The
he is.
result will be het always, and for type 2 the result will be tail.
No, 1 minute, 1 minute. If the person is type 2, then result is tell. Upon asking, the person replies the following: the result is toss. Is head. Yes. We have already done opposite, head to tail, so that is correct. Now, if he is type 1, then what happened?
Out of option A and B, how can I conclude the actual result?
Yes, we can conclude or not, that is the thing. So actually tail may be okay, means if it is type 2, then definitely it is tail. What happened if it is type 1? That only you have to check, because you have already, there are only two types. You have already checked that for type 2 it is tail. Now the remaining is type 1. So type 1 is telling truth, so result is toss. The result of the toss is head, means if it is head, so he is telling truth. Okay, so it is possibly, it is head also. One minute, if the person is type 2, then it is tail, correct. If the person is type 1, then you cannot find. If person is type 1, then what happened?
It is given and then the result should be het if and only if I am telling the truth. And telling the truth means type 1.
Okay, type 1 is telling truth. No, so actually this whole statement may be false also. If he is type 1, type 2, this is head. This statement is, just I am writing head if it is telling truth. So if it is type 1, okay, and now this is told by type 1. What is told by type 2? Type 2 is telling same thing, and type, the result of the toss is head. If I am telling truth, so he is telling truth or not, that you have to find. So how to find which of the following option is correct? Result is, if the person is type 2, then the result is tell. If the person is type 2, then he is not telling truth, and that, so this is definitely correct. There is no doubt in this, because if the result is, if the person is type 2, then he is not telling the truth, so toss is, the result is tell. That is definitely correct. Okay, but if the person is type 1, then what happened? If the person is type 1, then actually you are not sure. It can be head also, it can be tail also. Okay, so you cannot write only one option is correct here. Okay, clear? But similar type of questions are more tricky also. We'll see some question. Okay, now which one of the following is tautology? What about this one? First one is tautology or not? What is happening? You are changing x and y. So is it tautology? No. So this is not tautology. Correct. What about B? What about D? Means I am just going to simpler one first. What about D? But here it is x and here it is y. Like x likes y and y likes x. Both are different. For D option, that is also not correct. Clear? Because meaning is totally changed if you change the position over there. So this is also not correct. Now you have two options. For all x, there exists y . Yes, order is same. So that's why actually answer will be in B and C only. Order is same. For all x there exists y. Okay. So C is saying that this side and this side both are, means when there is biconditional means you have to say that both are equal. Okay, so you have to check that this and this both are same or not. For all x there exists y, yes, so this portion is okay. Now what it is done, pxy rxy, yes. So what is this? For all x, for this is same, so you have to check this portion only. So both are same or not. This is rxy. This is not of px, not of px. Same.
AC लगेगा सर?
ठीक है. Do you need AC? So this is not A or B. Same. There is nothing. So this is definitely tautology. Now look at the question. Although this question is very simple, but they have made it very complex. Means structured it complex. What about B? Oh, actually, if
It can't be because there is no R on the right hand side.
no, but that is not always true, because it is also possible that A or B, means A and B, that is possible.
No, but here it is like R tends to S,
Mm-hmm.
but there is only S.
Yes, yes, you are right that here it is not of R. Yes, this is only the correct answer. Yeah, you are right. But if here, it means here actually something or is there. So with or you cannot conclude this. Means A or B cannot conclude this one. This is wrong. With A and B you can conclude this. So whenever this, it means this or this, means not of or this. So whenever this, you cannot conclude like this, because here it is or. But if there is and here it is some for all, then definitely you can conclude. Means it is not there that R is not here, so you cannot say. And one more thing, here it is not equal, here it is implies. So you have to be careful sometime. In this question, definitely this is the correct one. Okay? Clear? Now tell me about this. This I think you can do. Correct. Yes, after that you just apply. Means this is if P then Q, and this you have already written. So now this is what? Not P or Q and not Q or P.
Which one? Option B.
Not P or Q, not P or Q. Yes, 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 this one. Anything else? Here it is and. This is definitely, and yes, this is also correct. Not P or Q and P or not Q. So this is also correct. Oh, question is not equivalent. Oh, yes. So this is also correct. So which one is not correct?
No, but first one is equivalent.
First one is equivalent. Is it clear? Second is also equivalent. Not P or Q and Q and P. This is this only. Second is also equivalent. What about third one? Third one is what? If P then Q or if Q then P. This is not same. Here it is or.
Actually, we can write that in the if P then Q because there is that and.
Oh, one minute. Sorry. Here it is and. Sorry. Yes, you are right. We cannot write like this. Here it is and. So what you can write? I thought it is or. So if it is or, you can write it. Here it is and, so you cannot write. So actually this is what, which one of the following is not? Okay. So these two things are equivalent to this. Now in this you have to think, this is what? Okay. Okay. Now actually it is very, we are doing like this, so we are confusing.
It's like
Hmm, hmm, hmm.
P if not
Actually this is also correct. This is also correct. Only this is not correct. How I am, how to better think? P, Q, I am writing 0 0, okay, or you can write, you can think like true false also. So okay, false false, false true, true false, true true. So in all these, what happened here? It is true, true, here it is false, here it is false. Is it clear? So what is this? This is what? For actually, where Q is also not true, Q is also not true, and P is also not true, or P is also true and Q is also true. Means this is written this thing. This thing is this one, and this thing is this one.
so it is correct. Means it is
Yes, this
equivalent.
is equivalent. So actually all these, all things are equivalent. This is not the equivalent. Okay, what is this actually? Not of PQ, not of O. So this is actually just not of PQ, means this or this. So actually this is opposite. This is something like XOR. Is it clear?
That statement and this statement are same.
Which statement?
Option C.
Option C, not of P. Yes, so this will become P or, okay, 1 minute. Yes, but this is in different format. Means just you have changed SOP to POS. Then it is okay. Is it clear?
So this
Hmm.
is different.
This is different. Means this is just change product of sum to SOP. Okay. Now this is clear. And this is also clear that how we have to change our strategy. Okay. Earlier we just have written the expression and then we have tried to solve. These things are there, but when this thing will come, we just change to this truth table. Okay. Now, so this is also one important thing, and this will help to solve question. This is actually equivalent to XNOR. You remember what is XNOR in digital logic? What is that?
That it's like this.
Yes. So what is this? AB plus,
If both are same, then it should be 1, and if different, it should be 0. The truth table.
if both are same, then this is,
1.
and if both are 0,
If both
Sorry, yes, both are same means both are 0. Yes, yes, if both are 0 then also it is 1, if both are 1 then also it is 1, but if both are different then it is 0. So that is the thing. Here also, if both are same it is 1, if both are different it is 0. So that's why this is XNOR. Okay, and what is this one? This is like XOR. So this is just opposite of this one. Clear? So now biconditional statement and XNOR condition both are equivalent thing. Okay. Later also we will means when we go to digital logic, then we will focus more in XOR. This is very important. Why XOR is important? Because XOR is when we do modular operation, okay, so that is XOR only. Okay, we'll see later. This is clear? Now this one. Try to solve yourself. If a candidate is known to be corrupt, then he will not be elected. If a candidate is kind, he will be elected. Two statements. Which one of the following statements follows from S1 and S2 as per sound inference rule of logic? Sound inference rule of logic means correct one. Option C. If a person is kind, he is to be corrupt. He is not known to be corrupt. Okay. How? What is the first statement? If a candidate is known to be corrupt, not elected. If a candidate is kind, he will be elected. Okay, correct. So you can write this one like this, means contrapositive of this statement is this one. Okay, so if it is kind, then he is not corrupt. Okay, this is clear. Yes, a person is known to be corrupt. He is kind, corrupt. So no, not person. So C is answer. And what about others? If a person is known to be corrupt, he is kind. From corrupt. Okay, 1 minute. From corrupt. So C is definitely answer. This is clear. This is also called chain rule. We have already seen. Now, if a person is corrupt. If a person is corrupt, he is not elected, and if he is not elected, then he is not kind. Corrupt, oh, he is. If a person is not known to be corrupt, okay, no, so you cannot. If a person is not kind, so not kind means not elected. Okay, so only C. Clear? Any doubt? Now this one. Not all rainy days are cold. This you do by yourself.
Option D.
Option D, there exists one day which is rainy day also and not cold. Yes, means there exists a rainy day which are not cold. Yes, correct. So you understood that logic, that actually not all rainy days are correct, means there exists at least one rainy day which are not cold. Okay. So actual thing is, whenever not all things is there, you always go to there exist. Similarly, not everyone, then you have to go to for all. Okay. Yes, now come to this one. Good mobile phones are not cheap. Cheap mobile phones are not good. Both are same statement or different one. Try to write it. So what is P? Means good mobile phones are not cheap. Okay. Cheap mobile phones are not good. Now, can you say that P implies Q? Means this is P, this is Q. So from P, can you say? What is contrapositive of this statement? What is contrapositive of first statement? Good mobile phones are not cheap. So this is can be written, if it is good mobile, it is not cheap. What is contrapositive of this statement? Is it clear? So both are contrapositive of each other. So both are same thing.
So basically,
Both are equivalent. Yes, good mobile phones are not cheap and cheap. So if I am saying good mobile phones are not cheap.
Both element are true.
So, okay, so in this question P implies Q, that is also correct. Q implies P, that is also correct. P is equivalent to Q, yes, that is also correct. So L, last option, LM, means all LMN is correct. Is it clear? So actually this question is very easy, just you have to know the contrapositive thing. Okay. Okay. So actually this is the last slide for question. Now a few things I left in predicate logic. One thing is called how to do blank space. Okay, like functionally complete set. You know universal gate. What is universal gate? NAND and NOR. Why?
Because with the help of that gate we can create.
Only NAND gate you can create all these gates. Similarly here also, means in, can I do within, no, that is. So here also functionally complete set. Functionally complete set means a set which can do all and or not things. Okay, means all connectives. For example, if I only, and NAND is noted by this sign I have not, NOR means like this. Okay, so only NAND is also functionally complete, only NOR is also functionally complete. Similarly, if I'll do OR and NOT, this is also functionally complete. And NOT, this is also functionally complete. What about XOR and NOT? Is it functionally complete? This is also functionally complete. If only XOR, is it complete? Can you, using XOR, you can make all the gates? You cannot make. Which gates you cannot make?
I mean, we can make gates using NAND and all.
Only using NAND you can make. But now I am giving two options, means more than one option. Means actually if you add NAND and OR, that is also functionally complete. Means if you add anything, it will be functionally complete only. Means functionally complete means it will represent all functions, all binary functions. Okay, so that is the functionally complete. Sometimes it is asked in exam that these sets are functionally complete or not, like that also. So now the predicate logic is, means proposition logic and predicate logic both are complete. Now we will go to set and relation. Okay, any question in this? This is clear? Okay, so 1 minute. हाँ, एक दूसरा सेट ये कीजिएगा।
इसको भी बंद करना है ना सर, ये
अच्छा।